You do it 100 times a day, right? You hit send and just don't even think about it. But have you ever stopped to wonder what is actually happening in that tiny sliver of a second? Well, we're about to pull back the curtain on that invisible, super fast journey your message takes. And trust me, it's so complex, it's kind of a miracle it works at all.
Seriously, just think about it for a second. You tap on a piece of glass in one part of the world, and almost instantly your friend on the other side of the planet is reading it. What fills that gap? It's not magic, not really. It's this incredibly precise dance between physics and code, happening at the speed of light.
All right, so to really get a grip on this incredible journey, we've got to start at the very beginning. Because underneath all the layers of mind-blowing technology, the goal of every single network is actually surprisingly simple.
At its absolute core, that's all communication is, getting a signal from point A to point B, from a server somewhere in a data center to your laptop right in front of you. But wow, that simple definition is hiding a whole universe of challenges.
And here's the real kicker. It's not just about getting some message to the other side. It's about getting an acceptable replica. The entire global internet is built on this one single promise, making sure the message you sent is exactly the message they get. No changes, no errors, no static.
So, let's do it. Let's follow one brave little message on its epic 5-step adventure. You can think of this as the roadmap for its entire life, from the moment it's created to the moment it's read.
Yep. Every single thing you send online, every text, every email, every cat video, it all goes through this exact 5-step path. Let's break it down, one step at a time. Okay, our journey starts right here, at the source. This is ground zero. It's you, typing a message on your phone or your computer asking a server for a web page. It's the birthplace of the data, the exact spot where an idea becomes a digital signal.
Next up, our message gets handed off to the transmitter. Now think of this as the message's personal coach and translator all rolled into one. It takes the data from your computer and encodes it, basically changing it into a format that can actually travel, as a light pulse in a fiber optic cable or a radio wave flying through the air.
And now things get a little dangerous. This is maybe the most treacherous part of the whole trip, the transmission system. This is the physical world, the actual cables under the ocean, the cell towers, the Wi-Fi signals bouncing around your house, and this world is full of peril for our little message. So check this out. A signal leaves home looking perfect, totally clean, but the real world immediately starts messing with it. It gets weaker the farther it goes. That's called attenuation. It picks up random static and garbage. We call that noise. And other signals can bleed into it. All of a sudden, our perfect message is a garbled mess.
So, who cleans up this mess? Well, that's the heroic job of the receiver. It grabs that weak, corrupted, messy signal and gets to work, trying to reverse all the damage. It boosts the signal, filters out the noise, and decodes it, all in an effort to piece the original message back together.
And finally, our message, against all odds, arrives at its destination. This is the screen where your text message actually appears, the speaker that plays the audio, the final stop where all that data becomes meaningful information again. The journey is complete. Phew. Now you might be wondering, how does this possibly work when you have billions of devices made by thousands of different companies all trying to talk to each other? Well, they all have to agree on the rules of the road. And in the world of networks, we call these rules protocols.
A protocol is really just a shared language. It's like agreeing that a red light means stop and a green light means go. Without these protocols, you just have digital chaos. You'd have billions of devices all connected, but none of them would be able to actually understand each other.
And for any protocol to actually work, it needs to define 3 key things. First, there's syntax. That's like the grammar, the structure of the message. Then you have semantics. That's the meaning. What do the messages actually mean? And finally, you have timing. Who talks when and how fast? If you mess up any one of these, the whole conversation falls apart.
Okay, so we followed a single message from start to finish. Pretty cool, right? Now let's zoom out a bit. How do we build a whole system that can handle trillions of these journeys all at once? It really starts with how we connect things together.
At a really high level, there are 2 basic ways to get a message out. You've got broadcasting, which is like a radio station. One signal goes out to everyone. It's a one-to-many, one-way street. And then you have point-to-point, which is much more like a phone call, a direct, private, and usually 2-way link between just 2 devices.
We can also think about the type of connection. Is it a dedicated link, like your own private highway where you're the only car? That's a point-to-point connection. Or is it a shared link, more like a busy street where lots of devices have to share the space and take turns? That's what we call a multi-point line.
And finally, how does the data actually move on these connections? Well, sometimes it's simplex, which means one way and one way only. Think about your keyboard. It only ever sends information to your computer. Sometimes it's half duplex, like a walkie-talkie. You can both talk, but you have to take turns. And the gold standard is full duplex, like a telephone call, where everybody can talk and listen at the very same time.
So, when you boil it all down, every network in the world is judged on 3 simple things. Performance? Is it fast with very little delay? Reliability? Does it actually work when you need it to? And security? Is your data safe from prying eyes? That's it. That's the trifecta of a great network.
Which brings us all the way back to where we started. That one simple, almost unconscious tap of the send button.
So if you take one thing away from this, it's this. What feels like magic is actually a small miracle of engineering. Every single time you send an email or make a video call, you're kicking off this incredible story of a message being packaged up, sent out into a noisy world, and then perfectly put back together on the other side, all because of a shared set of rules we all agreed on.
You know, it's pretty wild to think that we've more or less perfected the science of sending a flawless copy of data from point A to point B, almost instantly. It's fast, it's reliable, it just works. So that leaves a pretty big question, right? What comes next? What's the next great communication challenge we need to solve?